All right, today we are looking at a unique challenge affecting chemical management programs that use continuous injection pumps. This is a problem we call airlock. What is airlock? Airlock happens when a chemical injection pump, which often operates on a reciprocating piston or plunger, draws against an empty chemical tank or a closed valve. This draws air into the pump supply line, creating a vacuum that some pumps can't overcome. This leads to a loss of injection. The problem is quite common, and it often goes unnoticed for a long period of time. Today, we want to talk about how operations managers can identify and fix airlock from the comfort of their truck or office using WellAware On Demand Chemical. Let's get started. So we're looking at the WellAware On Demand Chemical platform, and you may recognize this site from our previous episode on finding and fixing empty tanks. This site had an empty tank, but we can actually see that now it's recovered. Unfortunately, we still have an injection variance problem. We're supposed to be injecting 18 gallons per day, but we're at and around 0. So the chart view in the WellAware On Demand Chemical platform helps us demonstrate what airlock looks like. So let's jump into the chart view. So as we look at the chart view here, we see the data that we saw previously in our episodes where the tank had actually run empty. If we isolate the black line here, which is the product volume, we see that the tank had run empty on September 27th, but then we notice that somebody refilled it yesterday, which is great. Unfortunately, we still have an injection problem. And if we actually look at the injection rate set point and compare that to the observed usage, we see where we lost injection when the tank ran empty, and unfortunately it hasn't recovered. This is a classic airlock scenario. What happens is the tank runs empty and then it's refilled. But unfortunately, because the pump set point was not turned off, that pump continued to inject against an empty tank, creating that air bubble and creating that vacuum. So even when the tank was refilled, that air bubble stayed in place and didn't allow the pump to inject any chemical. So how do we fix this? Well, there's a couple of ways to do it. One of the things is that we could look at chart screens like this and try to find this scenario. But let's be honest, we don't have the ability to look at chart screens all day. We've got work to do. Fortunately, WellAware has developed an airlock detection algorithm using our advanced analytics derived platform. So let's take a look at how that would work. So we've hinted at the idea that 4 scenarios need to be true for us to have a classical airlock scenario. The first is that we had a recent empty tank. The second is that we delivered chemical into that tank. The third is that we have a non-zero pump injection rate set point. And the fourth is that we generally don't have any observed usage. And as we can see here, those 4 scenarios are true. We look at the product volume trend line. We see that the chemical tank did run empty. We can look at our amount delivered, which is an automatic delivery detection algorithm that's available in WellAware On Demand Chemical. And we see that yes, about 450 gallons of chemical were delivered in that tank. So those 2 are satisfied. We see that our injection rate set point has been non-zero, and we see that our observed injection rate is still 0. So all of these 4 conditions are satisfied. And fortunately, WellAware has developed an airlock detector which checks for these 4 conditions. So if we isolate that airlock detector against the product volume and zoom in, we will see that sure enough, it has detected by going high that the airlock is a problem. So we can see that it's locked. So in the future, we can create an alarm that will identify and notify us of these airlocks. So we'll go to alarms. We can see we still have this active alarm from when the tank had run empty, but it's cleared because the tank was full. So I'm going to go ahead and acknowledge that. We know that it's fixed now, and that'll close that incident. But I want to create an airlock alarm. So I'll go to Edit Alarm Conditions. I'll add a new alarm. I'll select the pump asset, the airlock point, and this is a status type alarm. So I want to get notified when we have airlock, and so I want it to alarm when locked, and I'll set an alarm precedence of 50. Now I could also create a subsequent alarm to notify me when it's been cleared, but I won't do that for now. So now I'll get notified anytime airlock occurs based on those 4 conditions we talked about. But how do I fix that? Let's jump into the WellAware Field app to see how we can purge a chemical pump from the comfort of our truck to fix this problem. So I'm looking here at the WellAware Field app, and I am linked to the WellAware Connect device that is controlling this pump that has become airlocked. So I'm going to show us how we can purge the pump really quickly to fix this problem in many cases. So I'm going to connect to the pump application, and it takes me to my pump, and I see that I've got a max pump output of about 60 gallons per day. My current set point, as we saw on the web platform, is 18 gallons per day. So what I'm going to do is I'm just going to purge this pump. I'm going to click Start Purge, and I'm seeing that the air bubble is coming out of the line. And so I'm going to do this until I actually see chemical going through. Generally want to let this run for a little while until I actually visibly see chemical being injected. So I'll stop the purge, and there you go. That's all it takes. I can also do this from the web platform using the control application, just remotely setting the set point to the max pump output. It's as simple as that.